In this video, we're going to be talking about unit root tests. These are sophisticated tests that tell us about whether our data are stationary or not. When our data are non-stationary, then we say that the data have a unit root. How many unit roots are present in the data depend on really how many times do you want to difference the time series to make it stationary. So these tests would tell us how many times, whether first of all, whether the data are stationary or not, and second, how often do you want to difference your time series to make it stationary. So the first type of test is called the ADF test, which stands for Augmented Dickey-Fuller test. The null hypothesis for this test is that the data are non-stationary and non-seasonal. You really want to focus on the stationary part of it, so the data are non-stationary. Okay. The second type of test is called the KPSS test, which stands for Kwiatkowski, Phillips, Schmidt, Shin test. And the null hypothesis is reversed here, where the null says that the data are stationary. Okay, so you want to make sure that you are interpreting the p-values correctly when you're doing these different types of tests. But there are a host of other tests that are available for different types of data, for example, seasonal data. Now, let's say we were looking at the Google stock price, closing stock prices. We can use the features function, and we can put in an argument if we want to do the KPSS test, for example. So we're going to say features close, comma, unit root underscore KPSS, and this is going to give us some result here, which is going to be interpreted only if you know what your null hypothesis is. So in the KPSS test, the null hypothesis says that the data are stationary. So if your p-value is below 5%, then you would reject the null. In this case, your p-value is less than 5%. It's 2.5%. So we reject the null that the data are stationary. So we can conclude or infer that the data are non-stationary. Now, we knew this before we did the test, right? If you eyeball the Google closing stock price, then we can confirm this result as well, that the data are actually non-stationary. So what we can say then is that because the data are non-stationary, there is at least one unit root that is present in the data. Now, if we slightly morph our argument here, where we say unit root underscore ndiffs, okay, instead of calling the test, we are now calling ndiffs. Ndiffs is a command that tells us the number of times the time series needs to be differenced. That's why it's called ndiffs, number of differences that are required to make the time series stationary. So what we get here is a value of 1, which means that you must difference the time series once to make it stationary. And so you can play around with this. You can take Google underscore 2018, difference it once, call it something else, and then then use the pipe function on. Use the pipe function and then use the features function and then unit root ndiffs on that difference data to see if you actually get a 0, which you should if this is true. This is something that belongs to chapter 3, so I'm going to skip this for now. You can also automatically select the number of differences that you require for the seasonal component of your data. So if you morph the argument a little bit again here, where you say unit root underscore nsdiffs instead of ndiffs, this stands for the number of seasonal differences that are required to make the data stationary. And in this case, this returns a value of 1. Now, this data is not the Google data. This is data that is electricity generation for the United States. This is already in log, so this is telling you that the data has a unit root as far as the seasonal component goes, and you must difference it once. And here we are looking at a slightly manipulated version of that data itself, where we have taken the seasonal differences and we are again taking a look at whether we require the data to be differenced at all to make it stationary. So we're looking at this, in the first step here, we had looked at whether we need to seasonally difference our data, and the answer was yes, we need to difference it once. And then the second step, we have seasonally differenced our data here, and we are saying, do we now need to difference the data one more time, just the regular differencing? Okay, so this is telling us, yes, you still need to do that, and that's the number of regular differencing that is required. So you need to do first differencing in the second stage. So you can try this at home with the tourism data set.